Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Good evening. All right, children, we understood example 4 in the last class, but I just want to do it again.
Excuse me, ma'am.
Yes, Raja?
Sorry, ma'am. I did not see last meeting's recording.
Oh my God. No, that's difficult, Raja. Then today's, so I don't know if it will be very clear for you today. I don't know. Maybe you will understand. I can't say. Make sure that you watch the recording of the previous class and this class together. Okay.
Sure, ma'am. Sorry.
Yeah. No, but you should understand the difficulty in repeating, right? Anyway, the recording is there. So you have not, though you did not attend the class, the content of the class, the lecture during the class is recorded. So I don't think you really missed, like you can always make use of the recording and catch up with the class. Right?
Yes, ma'am. Sure. After the class, I'll see the recording.
Please do that here. All right, children. So see the cuboid here. This is the top face of the cuboid. This is the bottom face of the cuboid. This is the top face of the cuboid. This is the bottom face of the cuboid, correct? These are the side.
Yes.
These two are the side faces. And this one here is the back face, and the front face I cannot mark. This is the back face, and then there's the front face also. We know that a cuboid has 6 rectangular or some rectangular faces. When we say rectangular faces, some of the rectangular faces can be squares also. All cannot be squares, because if all the 6 faces are squares, then it is a cube. If all the 6 faces are identical squares, if all the 6 faces are identical squares, then it's a cube. Okay, so rectangle, a cuboid is a 6 rectangular faces. The faces opposite to each other are congruent. The faces opposite to each other. So the top face and the bottom face, the top face and the bottom face are congruent, meaning they're identical. The two side faces, the left and the right face, the two side faces are identical. They have the same dimensions. And the back face and the front face, the back face and the front face, they are also identical. So now this is the length. This is the length of the cuboid. This is the breadth of the cuboid. This one is the height of the cuboid. Height of the cuboid. Now, what are the dimensions of the front and the back face? What are the dimensions of the front and the back face? What are the dimensions of the front and the back face?
Length
Yes,
and breadth.
the front and the back face. Front face. This one. This is the front face. This is the front face.
Height and the breadth, ma'am.
This is the back face. This is the back face. This is the back face. What are the dimensions of the front and the back face? Length into height. Yes or no? The face is the length. This is the height. Length into height. Length into height. See here, length and into height. This is a rectangle, right? This is a rectangle. This is the rectangle. The dimensions are L into H. L into H. Similarly, the back face, length into height. Length into height. Because what is vertical is the height. This is vertical. It's the height. It's not the breadth. The breadth is this one. This is the breadth. This is the breadth. This is the breadth. This one is the height. What is vertical is the height. Length and breadth are horizontal. Length, breadth, they are horizontal. Height is vertical in a solid. So the dimensions of the front and back face, L into H. This is understood? Raja?
Ma'am?
Are you getting that?
Yes, ma'am.
Then tell me the dimensions of the side faces. This is a side face. This is a side face. This one is a side face. And this is the other side face. This is the other side face. What are the dimensions of the side faces? The side faces are congruent. They are identical. What are the dimensions of the side faces?
Ma'am, breadth into length into height, ma'am.
Length into height. Is it length into height?
Yes, ma'am.
No, see, I'll show you again. See here, this one. I'm talking about the side faces. This one. I'm talking about this one. Can you see B here?
Yes, ma'am.
And can you see H here?
Yes, ma'am. Ma'am?
Sorry. See, what is this breadth? This one is the height. Breadth into height is the area of the side faces. Let me draw it again. See here. Cuboid. All right, cuboid. This is the length of the cuboid. This is the breadth of the cuboid. And this one is the height of the cuboid. The front face, this is a rectangle. Rectangle. Length into height is the area. The area of the front face is length into height. The area of the back face is also length into height. Can you see that?
Yes, ma'am.
Now tell me the dimensions, or what will be the area of the side faces? The side faces. This is a side face. This one is also a side face. What do you see? What are the dimensions you see on the side faces? This is the breadth. This is the height. Like the length and the breadth of the rectangle. Yes. B and H. So B into H is the area of the side faces. The top and bottom face. The top face and the bottom face. The top face and the bottom face. This is the length. This is the length and this is the breadth. The top face, the top and the bottom face are identical. L into B. The area of the top face is L into B. Bottom face is also L into B.
Yes, ma'am. Now I can understand clearly.
Okay, now tell me top and bottom face, what's the area? Or what are the dimensions, top and bottom?
For the top and bottom face, length into breadth. Length into breadth, ma'am.
Yeah, side faces, the two side faces.
Breadth into height, ma'am.
Breadth into height. And the front and back face? Front and back face?
Length into height.
Length into height, correct. So please read the question. And I think you've taken a screenshot, children, in the last class. Have you finished this? Have you finished working this, children? Yes, ma'am. Okay, we can just revise the answer. the base, only the base, side faces, the base is only one face. Side faces are two faces, left and right side faces. Back face are to be covered with, so totally how many faces are covered with colored paper? Base is one face, side face is two, and back face is one face. So totally 4 faces. That means of the 6 faces, only 4 are covered with paper. Which are the faces not covered with paper?
Front face and
Front face and
top face, ma'am.
correct. Because we need to see the fish in the aquarium, right? If you cover it with color paper everywhere, so the front and the top face, they are not covered. The front and the top face. The front face and the top face. So of the 6 faces, 4 faces are covered with paper. The front face and the top face, they are not covered with paper. So you need to find the area of these faces. Add all the areas to find the total area of paper needed. All right, rather if you've not finished working now, take a screenshot and complete it. The internal measures of a cuboidal room are given to you. So the length, breadth and height are given to you. That is the order. LBH is the order always. Find the total cost of whitewashing all the 4 walls of the room. If the cost of whitewashing is ₹5 per, what will be the cost of washing if the ceiling of the room is also whitewashed? So let's understand the formula to find the area of 4 walls. That is the area of 4 walls, meaning, see, a room is cuboidal. The room here is cuboidal. The room here is cuboidal. Now, when we say area of 4 walls, we are talking about the area of the front face, back face, and the 2 side faces. That is not including the top and bottom. For a room, the top face is the ceiling and the bottom face is the floor for a room. If a room is cuboidal, the top face of the room, where the top face of the cuboid is the ceiling of the room. The bottom face of the cuboid is the floor of the room. The 4 walls of the room are the 2 side faces and the front and back face. Children, am I clear? Are you able to follow me?
Yes, ma'am. Yes, ma'am.
What is the top face for a room? What is the top face for a room? Top face of the cuboid for a room is the
Length into breadth, ma'am.
no. What is it? What do you call in a room? What do you call the top face?
Ma'am, ceiling, ma'am.
Ceiling. What do you call the bottom face?
Floor, ma'am.
Floor. And the 4 walls are what? The 2 side faces
faces,
and the front and back face. Correct?
Yes, ma'am.
Dania, am I not clear? You got it?
Yes, ma'am.
What makes the 4? the standing faces. The standing faces are 4 walls. Which are the standing faces? The cuboid, 4 faces are vertical. 2 faces are horizontal. In a cuboid, vertical. 2 faces are horizontal. The horizontal faces in the room are called the ceiling and floor. And the vertical faces in a room are called the 4 walls. There are 2 side faces and the front and back face. No, I'm just comparing a cuboid with a cuboidal room, like what we call the 2 side faces of the cuboid and the front and back face are the 4 walls of the room. The top face is the ceiling, the bottom face is the floor. Now, when we say area of 4 walls, children, when we say area of 4 walls, it is the correct. Is this correct? Children? Area means the area of the front face, back face, and the 2 side faces, correct?
Yes, ma'am.
Not clear? Not this. Remaining are walls. Not this is the ceiling. This is the floor. The remaining are the 4 walls. So of the 4 walls, one is the front face of the cuboid, one is the back face of the cuboid, and there are 2 more 4 walls. So see, this is 1 wall, this is the other wall, and these are the remaining 2 walls. 4 walls, 1 wall here, 1 wall here, and the remaining 2 walls, 4 walls. Is this understood? Please respond, children.
Yes, ma'am.
Yes, ma'am.
Now tell me the area of the front face. What is the area of the front face?
Ma'am, length into height, ma'am.
What's the area of the back face?
Same, ma'am. Length into height.
Okay.
Height
What
into
about the area of the side faces?
height into breadth, ma'am.
2 times, right?
Yes, ma'am.
Okay. Now tell me the area of the front face. Sorry, I'm asking you again. Class front face.
Ma'am, length into height, ma'am.
To height, ma'am. Length into height only, ma'am.
Side, left and right side.
Ma'am, height into breadth.
Both right. Okay, I think issue. You're trying to answer, but I'm not able to hear you. Now, tell me, how do we simplify this further?
Ma'am, 2LH plus 2BH.
What's common?
H is common, ma'am. 2H. 2H L plus.
Very good. This is the formula to find the area of 4 walls. We have found the area of each wall. We have found the area, the surface area of each wall. And we added everything to get the area of 4 walls. 2H into L plus B. 2H into L plus B is the, you just remember this formula. You just remember this formula. Area of 4 walls. Area of 4 walls of a cuboidal room is 2H into L plus B. Maybe you can write down this, children. Please write this. Yeah. Can I clear the slide?
Yes, ma'am.
All right. Raja?
Yes, ma'am.
Okay. So children, this is how we, understand the formula to find the area of 4 walls. Let's understand that better now. Now, when we say, when you call it a cuboid, we say the curved surface area of a cuboid, CSC of a cuboid, is equal to 2H into L plus B, because what you just found is the curved surface area of a cuboid. That is, see, when you look at it as a cuboidal room, then you say area of 4 walls. When it's a cuboid, when you call it a cuboid, then it is the curved surface area of the cuboid. Curved surface area is the area of 4 walls. The curved surface area is the 4 vertical surfaces. That is not including the top and bottom face. The 4 vertical surfaces. Cuboid, when you call it a cuboid, curved surface area of a cuboid is 2H into L plus B. We just derived it, square units, area, square units. When you call it a room, a cuboidal room, then it's the area of 4 walls. The area of 4 walls is equal to the same thing, 2H into L plus B. Now, what is 2 into, you can also write this as 2 into L plus B into H. 2H into L plus B can be written as 2 of L plus B into H. Now, what is this 2 of L plus B? 2 of L plus B.
Ma'am, 2L plus 2B, ma'am.
No. This formula we have seen earlier, no? In 6th and 7th standard, 2 into L plus B. What is 2 into L plus B? Okay, this is the floor, right? Can you all see the floor?
Yes, ma'am.
Okay, you can all see the floor. Now this is L, this is L. This is B, correct?
Yes, ma'am.
What's the perimeter of the floor?
Ma'am, it is perimeter of the rectangle, ma'am.
It's a perimeter of the floor, correct?
Yes, ma'am.
It's also the perimeter of the top. The perimeter of the top rectangle also will be 2 of L plus B, because this is L, this is L, this is B, this is B. 2L plus 2B. 2 of L plus B. See the floor, see the floor. LLBB, 2L, 2B. 2 of L plus B is the perimeter of the floor. So perimeter of the floor, perimeter of the floor, perimeter of the floor, or the base of the cuboid. See, when we say floor, it's the base of the cuboid. Perimeter of the floor into height. This is the other way of interpreting the area of 4 walls. This is the other way of interpreting the area of 4 walls. So tell after me, children. You don't have to unmute. Curved surface area of a cuboid is equal to 2h into L plus B square units. Curved surface area of a cuboid is nothing but area of 4 walls of a cuboidal room. That's also the same thing, 2h into L plus B square units. 2 into L plus B is the perimeter of the floor into height. So supposing you're not given the length and breadth, you're given the value of the perimeter. The perimeter of the floor of a room, the perimeter of the floor of a room is, supposing it's given to be some 75 meters. The perimeter of the floor of a room is 75 meters and its height is 10 meters. Find the area of 4 walls. The perimeter of the floor of a room is 75 meters and the height of the room is 10 meters. Find the area of 4 walls of the room. 75 into 10, 750 meters square. Two H into L plus B can be interpreted as the perimeter of the floor into the height of the room or the height of the cuboid. You can say perimeter of the floor into height of the room or perimeter of the base into the height of the cuboid. Perimeter of the base into the height of the cuboid. Write down this. Finish writing, children?
Just a minute, ma'am.
Okay.
Ma'am, what is the meaning of CSA, ma'am?
Sorry?
Ma'am, what is the meaning of CSA, ma'am?
Oh my God, this is perimeter. What else? I don't know what you're asking me. This is perimeter.
Ma'am,
Ma'am, like
what is the meaning of CSA?
Yes, ma'am.
This one, huh?
Yes, ma'am.
This one? You're asking this one?
Yes, ma'am.
Okay. Curved surface area.
Yes, ma'am.
Curved surface area, which means not the area of the top and bottom, only the curved surface area.
Yes, ma'am.
Okay.
Thank you, ma'am.
Okay, good.
I'm completed, ma'am.
All
Completed, ma'am.
yeah, good. So find the area of 4 walls. Find the area of 4 walls. You can write this formula straight away. You don't have to mention this also. Area of 4 walls is equal to 2 of L plus B into H. LBH is given. This is L, this is B, this is H. So you can just substitute 2 of L plus B into H. This is the area of 4 walls. For painting 1 meter square, it is 5 rupees. So for painting one whitewashing, okay. So for whitewashing 160 meter square will be 160 into 5, 800 rupees. If the ceiling is also whitewashed, if the ceiling also has to be whitewashed, the area of the ceiling, the top face is L into B. Area of the ceiling is L into B. Then cost of whitewashing the ceiling will be 96 into 5, 480. So the total cost of whitewashing the 4 walls and the ceiling will be 800 plus 480, which is 1,280 rupees. The floor will not be whitewashed, right? The floor will be tiled. The floor will be tiled. The 4 walls and the ceiling. Is my voice reaching you clearly, children?
Yes, ma'am.
Is it clear for all of you?
Yes, ma'am. Ma'am, but sometimes it is not clear, ma'am.
Okay. Now please let me know if you understood this answer. Area of 4 walls. In this question, we are asked to find the cost of whitewashing the 4 walls first, and then supposing you whitewash the ceiling also. Whitewashing activities like this painting activity. What is done before painting is whitewashing. Before painting, the surface is whitewashed. So if only the 4 walls are whitewashed, what is the cost? Supposing the ceiling is also whitewashed, then what is the cost? That's the question. Please mark the answer and let me know if you understood. Don't write this is not needed. Done?
Yes, ma'am.
Yes, ma'am.
Yes, children, you must ask, understand something. Please ask me. Any doubts?
No, ma'am. No, ma'am.
In a building, there are 24 cylindrical pillars. The radius of each pillar is 28 centimeters and the height is 4 meters. Find the total cost of painting the curved surface area of all the pillars at the rate of ₹8 per meter square. So now we need to understand about a cylinder, area of a cylinder. Okay. So this is a cylinder, and you can see that a cylinder has two circular faces. The top face is circular, the bottom face is also circular. Now, if you don't include the area of the top and bottom face, the rest of it is the curved surface area. This is the curved surface area of the cylinder. The curved surface area is this area, like this one. This is the curved surface area. Don't you go around the pillar? You hold the pillar with one hand and you go around it, no? So that is the curved surface area. Curved surface areas, the area not including the top and the bottom. Top is a circle. The top of the cylinder is a circle. The bottom of the cylinder is also a circle. The two circles are congruent circles. They are identical circles. They're identical circles. So the curved surface area is the area of the cylinder, not including the top area and the bottom area. That is not including the area of the circles. If you don't find the area of the two circles, the remaining area is the curved surface area. Now, you know, in temples, we see that the cylindrical pillars, if the pillar is cylindrical, the top and bottom, they are stuck. The top is stuck to the ceiling. The bottom circle is stuck to the floor, correct? Can you see the circular portions of the top and the bottom?
Yes, ma'am.
No, the answer is not yes, it's no. We cannot see the top circle and bottom circle because the top circle is stuck to the ceiling. And the bottom circle is stuck to the floor. See here, you cannot touch the circle on the top. You cannot touch the circle. See, now supposing you have a cylindrical, okay, these markers, whiteboard markers are cylindrical. Okay, whiteboard markers. You please think of a sketch pen which is cylindrical. All of you got that? Can you see in the sketch pen, can you see the circle on the top and bottom? Yes, you can see, because you can lift the sketch pen and see the area, the circle at the bottom and the circle on the top. Yes or no?
Yes, ma'am.
Just think of a cylindrical sketch pen or a whiteboard marker. It's cylindrical. That is with the cap, I'm saying. Don't remove the cap and ask me. With the cap, when you buy it from the shop, it is cylindrical. So it has the curved surface area, the area of the top circle and the area of the bottom circle. You can touch the top circle, you can touch the bottom circle. But when you take the case of pillars in the temple, cylindrical pillars in the temple, the top circle is stuck to the ceiling. The bottom circle is stuck to the floor. So if you want to paint, what is the difference between painting the marker and painting these pillar? When you want to, if you want to paint the marker in your hand, you can paint the curved surface area. You can paint the circle on the top. You can paint the circle below. But if you have to paint, so you can paint the total surface area of the cylinder. You can paint all the area that is available in the cylinder in the case of a marker. In the case of a cylindrical marker, if you want to paint the pen all over, you can paint the curved surface area, the top circle and the bottom circle. No more areas left to be painted. So you can paint the total surface area of the marker. Total surface area is the curved surface area, the area of the top and the area of the bottom. Now when you come to the pillars in the temple, the cylindrical pillars in the temple, if you want to paint them, you cannot paint the top circle because you can't see it. It is stuck to the ceiling. You cannot paint the bottom circle because you cannot lift and paint it. It's stuck to the floor. Then what area is available to be painted? Only the curved surface area. And now we'll try to understand the formula to find the curved surface area of a cylinder. Now we'll understand the formula in detail next year. Now for now, whenever it is curved surface area of a, I'll say solid now, but actually I should say the CSA of a solid with uniform cross section. I'm not using that word for you now because you don't have to know that for the standard. So the curved surface area of a solid. Now the curved surface area of a cylinder is the perimeter of the base. Like how the curved surface area of a cylinder is equal to perimeter of the base into height of the cylinder. Now go back what we did know. See at perimeter of the floor. Perimeter of the floor into height is the curved surface area. Perimeter of the base into height. Perimeter of the base into height is the curved surface area. Similarly here, perimeter of the base into height is the curved surface area. Perimeter of the base into height is the curved surface area. How is the base like in a cylinder? What is the shape of the base in a cylinder?
Circle, ma'am.
Circle. What is the perimeter or the circumference of a circle?
2 pi r, ma'am.
2 pi r. 2 pi r. So perimeter of the base is 2 pi r. Why 2 pi r? Because the base is a circle. And what's the perimeter or circumference of a circle? 2 pi r. And let's say the height of the cylinder is h. So into h. So that is 2 pi rh. 2 pi rh square units. 2 pi rh square units is the formula to find the CSA of a cylinder. You can just break it up in your mind. CSA, perimeter into height. Perimeter of what? Perimeter of the base. How is the base? Circle. What's the perimeter of a circle? 2 pi r. 2 pi r into height, h. 2 pi r h. 2 pi r h is the formula to find the curved surface area of a cylinder. Write down this. Write down this formula. CSA of cylinder is equal to perimeter of the base into height. All right, now coming to this question. In a building, there are 24. Okay, this is a building which has 24 cylindrical pillars. Okay. So in the pillar, you can only see the curved surface area because the top and bottom, they're stuck. Only CSA you can see and paint. The radius is given. Yeah, in the formula, what you have two values, 2 pi RH. 1 minute, I'm not getting the pointer. Yeah, okay. So this is the formula, 2 pi RH. 2 into pi is 22/7 into radius. What is the radius? Radius 28. 28 into height. Height is 4. So this is the curved surface area of one pillar for 24 pillars into 24. This is the curved surface area of one pillar, 24 pillars into 24. So find the total cost of painting the curved surface area of all the pillars at ₹8. So find this answer and multiply this by 8. Because for 1 meter square, it is ₹8. So for 1 meter square, it's ₹8. 1 minute, I think there's a printing mistake here. This should be in meter. Not a printing mistake. Sorry, I made a mistake in typing maybe. I found it in centimeter square. But the height cannot be in centimeter, no, for a pillar. Let me just look into the question, children. I'll just confirm the units, children. Just give me a minute. I'll confirm the units because it cannot be 20. Oh, radius is 28 centimeters. Oh, yeah. Okay. And the height is 4 meters. Fine. All right, children, I didn't notice. The radius is 28. It's fine. It's correct. The radius is 28 centimeters and the height is 4 meters. Correct. The height of the pillar is 4 meters and the radius is 28 centimeters. Fine. So going back to this, we should find the CSA of one pillar, 2 pi RH, multiply by 24 to get the area of 24 pillars, and then to find the cost, multiply by 8. So now, the CSA of 24 pillars is 24 into 2 pi RH. Is this correct? Is this correct, children? So 24 into 2 into 22/7 into radius is 28 centimeters. And height, because it's 4 meters, I've taken it as 400 centimeter. It should be in the same unit. You cannot take radius in centimeter and height in meters. Either both should be in centimeter or both in meters. So I've taken 28 centimeter, 400 centimeter. So the answer will be in centimeter square. And we need to convert that to meter square because the rate is given per meter square. 1 meter square is ₹8. So we need to convert this area to meter square. To convert centimeter to meter, we divide by 100. Centimeter square to meter square, I told you in the last class, divide by 200s. Not 200, 200s. Divide by 100 2 times. To convert centimeter to meter, you have to divide by 100. For example, 5 centimeter is 5 by 100 meters. 5 centimeter square is 5 by 100 into 100 meter square. Do 2 times. So this is in centimeter. This is also in centimeter. So the answer area is in centimeter square, but we have to convert it to meter square. So divide centimeter to meter, divide by 100. Centimeter square to meter square, divide by another 100. Then it's converted to meter square. And you can understand this. Place a decimal 1, 2, 3, 4. 1, 2, 3, 4 here. 168.96 meters square. Now the cost of painting is CSA into rate. So CSA into rate, which is this one. Yes, write down, children. Painting, okay. This painting. Is it over, children?
Yes, ma'am.
Yes, ma'am.
Now you must tell me what. Explain again. What area to find means you should find only the area that is painted. That is a curved surface area. And when you're substituting the values, everything should be in the same unit, either both in centimeter or both in meters. If you give the value in centimeter, the area will be in centimeter square. If the values are in meter, then the answer will be in meter square. Now for the same thing, supposing you did this, say 24 into 2 into 22 by 7. For radius, if you took 28 by 100, you understand what is 28 by 100? That means you're converting radius to meters. 28 by 100 meaning you're converting this to meter. Then you can take the height as 4 itself. Then this answer will directly be in meter square.
Yes, ma'am.
If you take the radius as 28 by 100 meters, then you can take the height also in meters, 4 meters. Then the answer will be in meter square. So you don't have to convert. Just multiply by the rate to get the cost. Now coming to the total surface area, children. Now let's understand the formula to find the total surface area of a cylinder. Total surface area of a cylinder. Okay. Total surface area of a cylinder is equal to the curved surface area plus area of 2 circles. Okay, or let me make it like this, area of the plus area of top circle plus area of bottom circle. What is the CSA? What does the CA say?
968 centimeters square, ma'am.
No. We are deriving the formula. What is the CA say formula?
Perimeter
2 pi RH, ma'am.
2 pi.
by R
RH, ma'am.
What's the area of the top circle?
Pi R, ma'am.
Pi r. Huh? Area of a circle.
Pi R square, ma'am.
What about the bottom circle?
2 pi r, ma'am.
Pi R square, ma'am.
So how to simplify this?
Plus 2 pi R square.
What's common?
2 pi R is common, ma'am.
Bracket.
H plus R.
Or you can say 2 pi r into r plus h. Square units because area. So you remember this formula, that's all. TSA of a cylinder. The cylinder is equal to 2 pi r into r plus h. 2 pi r into r plus h. Total surface area is the total area of the cylinder. So what makes the total area of the cylinder? The curved surface area, the area of the top, the area of the bottom. So CSA is 2 pi RH. Top is pi r square, bottom is pi r square because both are circles. Then on taking the common factor and all that, we get 2 pi r into r plus h. The CSA formula is 2 pi RH square units. TSA is 2 pi r into r plus h square units. Please write on this. See children, now don't ask me if we should remember all this. This is just for you to understand. All this is just for you to understand. You need to remember this formula. 2 pi r into r plus h square units. This is the understanding behind the formula. How we get that formula? How we get the formula? Finish writing, children?
Yes, ma'am.
All of you? We're only 3 in the class.
Yes,
Three of
ma'am.
today.
Yes, ma'am.
Kirtana is there. Kirtana, you joined us late, is it? Are you there, Kirtana?
Yes, ma'am.
Devadarshini, you two joined late, is it? Okay, I did not know. When we started the class, I saw Raja, Sindhu, Sanjay, and Danya. Okay, so I did not know that Kirtana and Devadarshini have also joined the meeting. All right. So are you both following?
Yeah,
Kirtana?
ma'am. Yeah, ma'am. I'm writing, ma'am. I joined 6:10, ma'am.
Okay, fine. Okay. All right, finish writing, children. Is it understood?
Yes, ma'am. Yes, ma'am.
Okay. Now, this is the knowledge regarding how the formula is derived. Okay. So you have to remember that TSA of a cylinder is given by the formula. TSA of the cylinder is given by the formula 2 pi r into r plus h. Now let's answer this question. Find the height of a cylinder whose radius is 7 centimeter. So it's about a cylinder. It's about a cylinder. The radius is 7 centimeter. Find the height. We don't know the height of the cylinder. We have to find what is given. The TSA of the cylinder is given to be 968 centimeters square. The height is 7. So sorry, the height is not known. Radius is 7. Total surface area is 968. This is given to us. So we work like this. We work with the help of the total surface area. The total surface area is equal to 968 centimeters square, which means 2 pi r into r plus h is equal to 968. 2 into 22 by 7 into r, the value of r is 7, into r plus h is equal to 968. Please solve this and tell me the value of h. See here, TSA is 968 is given to us. The formula to find the TSA is 2 pi r into r plus h. That's equal to 968. Now substitute the values. We know the value of r is 7. H is what we have to find. You can see that in this equation, there is only one unknown h. There's only one unknown h. So solve this equation and find the value of h. Do that, children.
Completed, ma'am.
All right, Danya. Just wait for the others to complete.
Completed, ma'am.
Okay. What's the value of h, children?
15, ma'am.
15, huh?
15 centimeter, ma'am. Yes, ma'am.
Okay, 15 centimeters. Let's see. So 7 gets cancelled. And we have 2 into 22. You can even multiply or have it as 2 into 22 into 7 plus h. Yeah, okay. You can write it as 44 also. So 7 plus h is equal to 968 divided by 2 into 22. So 2, how many times 2? 4s are 1, 2 8s are 16, and 2 4s are. And in 22, 22 times. 22 times is 484. So on simplifying, 7 plus h is equal to 22. H is equal to 22 minus 7. H is equal to 15. Yes, you're right. H is equal to 15 centimeters. So the height of the cylinder is 15 centimeters. We don't have to multiply. So here 7 and 7 will get cancelled. You don't have to multiply. It's okay if you multiply, but better you don't. 2 into 22. So you will get 2 into 22 here. It's okay if you multiply also. If you multiply, you can see the working here. You don't have to multiply. 2 into 22 comes down for division. Is it over? Complete, children?
Yes, ma'am.
Okay. All right, children. Now take a screenshot of this one. Please finish this as homework. That's all. I don't think you can do this one. Don't do this. Yeah, do this one, children. Complete this one. You can do this. Please do this one.
Taken, ma'am.
All right. Yeah, you can just try this. We'll discuss these answers, children. Don't worry. Please do this. Lateral surface area means curved surface area. Lateral surface area means curved surface area. Yeah, you have to do this, children. Take a picture. You have to do this one. Where's the answer? Oh, I don't have the answer for this. The answer. For that I don't have the answer. 1 second. Okay, only finish till here, children. All right, children. So that's it for today's session. Thank you so much.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.